Welcome to Cosmic Sense, the podcast that dares to ask the big questions. I'm your host, Ali, and I'm Sarah.
Here to ignite your curiosity,
Challenge your perspective and take you on a journey beyond the ordinary. Ready to expand your mind and spark some cosmic sense? Let's dive in. Today, we're going to tackle one of the biggest mysteries in the universe, the Fermi Paradox.
Yeah, the one that asks, where is everybody?
Exactly. If the universe is as vast and as old as we think it is, statistically speaking, it should be teeming with alien civilizations. Have you ever looked up at the night sky and just felt that shiver of wonder, looking at all those stars and thinking, are we alone?
It's a question that's kind of fascinated humanity for centuries, really. But it was a physicist, Enrico Fermi, who really kind of threw a wrench in the works with what we now call the Fermi Paradox.
Right. It's like this cosmic reality check.
Exactly.
On the one hand, you've got just the sheer size of the universe, all those galaxies and star systems, and it makes it seem almost statistically impossible that Earth is the only planet with life. But then on the other hand, where is everybody? No spaceships on the White House lawn, no intergalactic welcome wagon.
What's so fascinating about the Fermi Paradox is that it goes beyond just, wondering if aliens are out there. It forces us to confront the potential vastness of life in the universe,
Right.
While simultaneously grappling with the complete lack of evidence for it. And it's a puzzle, with implications that could, reshape our understanding of everything.
So how did this whole paradox thing get started?
Well, the story goes that back in 1950, Fermi was having a casual lunch with some colleagues, and, this very question popped up. And given the age and vastness of the universe, he reasoned, some civilizations should have had ample time to develop interstellar travel. And, if they had, why haven't we seen any signs of them?
Yeah, that's a good question.
And that simple lunchtime musing kind of snowballed into what we now know as the Fermi Paradox.
Okay, so let's start by looking at some of the most common explanations, the usual suspects people have come up with to try and solve this cosmic riddle.
The classic solutions.
Right. And one of the biggest hurdles we face is the mind-blowing difficulty of interstellar communication. I mean, even if we were sending out signals into space, the distances involved are just
incomprehensible.
Yeah, pretty much. It would take an insanely long time for our signals to reach even the closest star systems, and then even longer, if ever, to hear back.
It's like trying to have a conversation with someone on the other side of the world, but instead of seconds, it takes centuries for your message to reach them.
The source material actually had a really great analogy to illustrate this point.
Oh, yeah.
They compared our search for extraterrestrial signals to scooping a single glass of water out of the ocean and expecting to find a fish.
That's a good one. The universe is just that vast compared to our little search efforts.
And even if, by some cosmic miracle, our signal did reach another civilization, how could we even be sure they'd understand it?
That's another huge problem. What if their technology, or even their whole way of thinking, is so different from ours that they wouldn't recognize our attempts at communication as anything more than random noise?
It's like trying to explain the internet to, the caveman.
Right.
They just wouldn't have the framework to even grasp the concept.
Exactly. And to make things even trickier, there are the practical limitations of our technology. One of our sources mentioned that to even have a chance at detecting signals from hundreds of light years away, we'd need a radio telescope the size of Chicago.
Wait, seriously, a telescope the size of Chicago?
Yeah, that's what they said. And get this, the estimated cost would be over $60 trillion.
Okay, so eavesdropping on alien conversations is definitely not in the budget. So maybe the problem isn't just distance. What if the conditions needed for intelligent life to even arise are just incredibly rare?
Well, that leads us to the rare Earth hypothesis, which suggests that planets like Earth, capable of supporting complex life, are incredibly uncommon.
So we really did win the cosmic lottery, huh?
It seems that way. The perfect distance from the sun, liquid water, a stable atmosphere, plate tectonics, all these factors coming together just right. It's a pretty rare combination.
And then there's the whole journey from simple life to intelligent beings who can build civilizations. That's another long and tricky path, full of evolutionary hurdles.
It is. It's possible that while basic life might be relatively common out there, intelligent life is incredibly rare.
So we've got communication as a nightmare, and the odds of finding another intelligent civilization are astronomically slim. A cosmic outlier. That puts a whole new spin on the idea of protecting our planet, doesn't it?
It certainly does. It raises the stakes significantly. If we truly are alone, then the responsibility for preserving the only known example of intelligent life in the universe falls squarely on our shoulders.
No pressure there. But there's another possibility we need to consider. What if there are advanced civilizations out there, but they're intentionally keeping quiet?
Like they're hiding. Why would they do that?
That's where we get into the dark forest theory, a pretty chilling idea inspired by science fiction. It suggests that civilizations might be hiding out of fear.
Fear of what?
Fear of attracting the wrong kind of attention. Think of it like hunters in a dark forest staying silent to avoid becoming prey.
So they're basically going radio silent to avoid being detected by potentially hostile aliens.
Exactly. It makes you wonder if we should be broadcasting our presence to the cosmos.
Yeah, maybe we're putting a target on our own backs by trying to make contact. It's a disturbing thought, isn't it? But let's say for a moment that there are super advanced civilizations out there. What if they just don't care about us?
Like, we're not interesting enough to bother with.
Right. Imagine a civilization millions, maybe even billions of years ahead of us technologically.
It's hard to even imagine.
We might be like ants to them beneath their notice. They wouldn't spend their time trying to have deep philosophical conversations with ants. And maybe they see us the same way.
Ouch, that's a bit of a blow to the ego. So we've covered communication barriers, the rare earth hypothesis, the chilling dark forest theory, and the possibility that aliens are just bored with us. Anything else we should be considering?
Well, there's a more philosophical angle to consider as well. The anthropic principle suggests that we can only observe a universe where certain conditions are met, including the absence of galaxy-dominating civilizations or runaway artificial intelligence that would have wiped out everything.
Because if those events had happened, we wouldn't be here to observe the aftermath. So our very existence suggests that those civilization-ending scenarios are either rare or haven't happened yet.
Exactly. It's a bit of a head spinner, but it adds another layer to the Fermi Paradox puzzle. But what's truly fascinating is that there are even more radical solutions out there, challenges to the very assumptions we make about the universe and our place in it.
Okay, now you've really got my attention. What are these radical alternatives?
One particularly intriguing solution comes from author Vojislav Rakic at the Center for the Study of Bioethics at the University of Belgrade. His work tackles the Fermi paradox from a completely different perspective, focusing on the limitations of human perception and understanding it's called the lasting human epistemological limitation solution.
Lasting humans, say that 10 times fast.
Right. The idea that maybe the answer to the Fermi paradox isn't out there in space, but rather right here.
Right here.
Yeah.
I mean, like, on Earth.
Well, not exactly on Earth, but within us. What if the reason we haven't found aliens is because of limitations in our own perception?
Whoa, okay, slow down a second. What do you mean by limitations in our perception?
What if there are whole dimensions, whole realities existing right alongside ours that we're just completely blind to? Like, what if our senses and our science are just not equipped to see them?
Okay, you're talking about like parallel universes, alternate dimensions, that kind of stuff.
Yeah, but it's even more than that. It's not just about aliens cleverly hiding in some other dimension. It's about the possibility that we're missing a huge chunk of reality because we're literally not built to perceive it. It's like, imagine you're looking through a tiny peephole and thinking that's all there is to see.
I'm trying to picture it. Give me an example.
Okay, think about a little bug crawling on a leaf.
Oh.
That bug's whole world is that leaf, right? It can't see the trees, the sky, the humans watching it.
Oh, I see where you're going with this.
That bug is totally oblivious to a whole world that exists just beyond its senses. And maybe we're like that bug, totally unaware of all this stuff happening around us because we just don't have the right senses or even the right ideas to grasp it.
So you're saying that aliens could be all around us, but we're just missing them because we're not tuned into the right channel.
It's possible. And one guy who really dove into this idea is Vojislav Rakic. He connected it to the work of a philosopher named Immanuel Kant.
Oh yeah, I've heard of Kant.
Kant argued that we humans are limited by the way we experience space and time. He called these limitations our a priori forms of apperception.
A priori forms of apperception. I always thought that sounded kind of intimidating. Can you break that down for me?
Sure, think of it like this. Imagine you're wearing glasses with, say, blue-tinted lenses. Everything you see will look bluish, right? You might not even realize the world isn't actually blue. That's just how your glasses are filtering things.
Okay, so Kant is saying our minds are like those blue-tinted glasses. They kind of shape and limit how we experience reality.
Exactly. And he believed that those limitations might be keeping us from experiencing a whole lot of stuff that's actually out there. And what's really interesting is that modern physics might actually back this up.
Wait, really? How so?
Well, you know how physicists talk about the curvature of space-time or the idea of parallel universes?
Yeah, those concepts always kind of make my head spin.
They are pretty mind-blowing, aren't they? But if these ideas from physics are even partially right, it means reality is way weirder and more complex than we thought. And maybe there are all these other dimensions or realities existing that we just can't grasp yet.
So if we're limited like this, how can we even begin to explore those other realities? Seems kind of hopeless.
Well, it's a tough question. But maybe the first step is admitting that we don't have all the answers. Like, we need to cultivate a beginner's mind, to use a term from Zen Buddhism. We have to be open to the possibility that we're missing a whole lot.
So we need to basically upgrade our mental operating system, find new ways to perceive and understand the universe.
Exactly. And that might mean pushing the boundaries of science, exploring consciousness through things like meditation, even drawing inspiration from art and imagination.
So are you saying the answer to the Fermi paradox might not be out there in space at all, but right here in our own limited way of seeing things?
It's definitely a possibility. It's like that saying, what you seek is seeking you. Maybe the answer has been right here all along, and we just haven't been able to see it.
That's both humbling and exciting.
It is. And it leads us to an important question for you, our listener. If we could somehow break free from these limitations, what amazing things might we discover? What hidden realities might suddenly become visible? If there are all these other realities out there teeming with life that we can't even imagine, then it's possible that life as we know it is actually pretty common. It's just that we're stuck in our little corner of the universe thinking it's the whole shebang.
It kind of makes you wonder, though, if we're this limited, is the search for alien life even worth it? Should we just give up?
No way! It just means we need to get more creative, more open-minded. We can't expect aliens to be like us or to follow our rules.
So we need to find new ways of perceiving, new ways of understanding the universe, maybe even look inward as much as we look outward.
That's it. It's not just about bigger telescopes. It's about expanding our own consciousness, pushing the boundaries of our imagination.
It's been an amazing journey exploring the Fermi paradox and this idea that we might be limited in what we can even perceive. It's a little unsettling, sure, but also pretty darn exciting.
Definitely. The universe is full of mysteries, and maybe the biggest one is right here, inside our own minds.
This has been an incredible start to our deep dive into the Fermi paradox, from the origins of this cosmic puzzle to the mind-boggling solutions that challenge our understanding of reality. It's clear that the search for extraterrestrial intelligence is about so much more than just finding aliens. It's about exploring the very nature of existence, our place in the universe, and the limits of our own knowledge.
And we've only just scratched the surface.
That's right. Stay tuned for part 2 of our discussion, where we'll delve into the theological interpretations of the Fermi paradox and explore the Islamic perspective. Things are about to get really interesting.